Air travel was exploding while the entire system was breaking under the pressure. Airports were choking, runways were maxed out, and the industry faced a problem no one could ignore. Two giants looked at the exact same data and saw completely different futures. Airbus made a bold bet: go bigger than ever before. Pack more passengers, dominate crowded hubs, and build the largest aircraft the world had ever seen. On the other hand, Boeing went the opposite direction. Smaller, smarter, more efficient planes. Skip the chaos. Connect cities directly. Rewrite how the world flies. Billions were on the line. Two visions, one future, and only one of them got it right. Understanding how Boeing killed the A380 requires going back to 1995. That year, Boeing introduced the 777, a twin-engine wide-body that fundamentally changed long-haul aviation. Airbus competed with the A340, 4 engines, similar passenger capacity to the 777, comparable range capabilities. But the economics told a brutal story. 2 engines burn less fuel than 4 engines. The advantage is not subtle. It is overwhelming. Airlines noticed immediately when comparing operating costs. Airbus sold 377 A340 aircraft total across the program's entire lifespan. Boeing has moved over 2,200 copies of the 777. The market delivered a 6-to-1 verdict. But here is what makes this fascinating. 20 years before the 777 launched, Boeing could not legally build that aircraft. Not because of technology limitations, because regulations prohibited it. Aviation rules for decades enforced the 60-minute limitation. Twin-engine aircraft could not fly further than 60 minutes from the nearest airport. The reasoning was sensible. If one engine fails over the ocean, the aircraft needs reaching land before the second engine quits. Crossing oceans required 3 or 4 engines. This was not preference, it was law. The Boeing 747 exists because of this rule. The DC-10 exists because of this rule. The A340 exists because of this rule. Then, engine reliability improved dramatically. The FAA recognized this and changed regulations in 1985. TWA received authorization to fly twin-engine Boeing 767s from Boston to Paris. The first long-haul over-water twin-engine approval ever granted. That Boeing 767 consumed 7,000 pounds less fuel hourly than the 3-engine aircraft it replaced. Airlines watched these savings compound across thousands of flights. By 1991, twin-engine Boeing 767s were carrying more transatlantic passengers than all 3-engine and 4-engine aircraft combined. The transition happened shockingly fast. Regulators kept extending the limits, from 120 minutes to 180 minutes to 330 minutes. By the mid-2000s, twin-engine aircraft could fly anywhere 4-engine aircraft could reach. The fundamental rationale for 4 engines had vanished completely. Airbus actually recognized this partially. They developed the A330 alongside the A340, identical airframe, identical fuselage, built together to reduce costs. The A330 received 2 engines. The A340 received 4. Today, the A330 continues flying and receiving orders. The A340 stopped production in 2011. Same basic airplane, different engine count, totally different commercial fates. So Airbus watched their 4-engine aircraft get crushed by Boeing's twin. Then they decided building an even larger 4-engine aircraft made sense. This sounds irrational until you understand what happened before. Boeing actually tried building a super jumbo first. In 1996, Boeing showed airlines designs for the Boeing 747X, a stretched double-deck Boeing 747 carrying over 650 passengers. The ultimate version would extend the famous hump all the way aft. Airlines expressed interest, but would not commit. Boeing kept adding features. Costs kept climbing. Market projections showed maybe 70 to 80 sales over 9 years. Development would cost over $5 billion. The economics failed. Boeing killed the program in early 2001. Airlines had rejected the super jumbo concept decisively. Airbus observed Boeing's failure, then proceeded anyway. December 2000, Airbus launched the A380 program, budget established at 9.5 billion euros. 50 firm orders from 6 airlines secured. Airbus sold the A380 differently than Boeing marketed the Boeing 747X. Boeing positioned their aircraft as a derivative, a bigger version of something existing. Airlines compared it to current capabilities and declined. Airbus positioned the A380 as revolutionary, full-length double-deck, onboard bars, lounges, showers. They copied Boeing's original Boeing 747 marketing strategy. Sell to prestigious carriers first. Create competitive pressure, forcing others to follow. Emirates, committed. Singapore Airlines, committed. Qantas, committed. When those airlines buy something, competitors fear falling behind. The cost per seat pitch was genuine, 15 to 20% lower than the Boeing 747. One A380 replaces 2 Boeing 747s on the same route. Uses 1 airport slot instead of 2. At slot-constrained airports like Heathrow, that argument carried weight. Meanwhile, Boeing was experimenting their way toward the answer. March 29, 2001, the exact day Boeing confirmed canceling the Boeing 747X, they revealed the Sonic Cruiser. This aircraft looked futuristic. Delta wings, canard configuration, nearly Sonic cruise speeds, approximately 225 passengers, the complete opposite of the A380 philosophy. Airbus bet on size, Boeing bet on speed. Some airlines showed interest. Virgin's Richard Branson anticipated ordering 3 to 6. American Airlines expressed curiosity. Then, September 11th happened. Air travel collapsed overnight. Airlines hemorrhaged $13 billion in losses that year. Another $11 billion the following year. 1,000 aircraft were parked. Speed stopped mattering. Size stopped mattering. Only efficiency mattered. Every fuel dollar burned became critical. Boeing maintained the Sonic Cruiser for over a year, but by December 2002, it was terminated. However, they did not abandon the technology. Carbon fiber composites, advanced engine architecture, new avionics, everything developed for the Sonic Cruiser got redirected. They built a different aircraft entirely. Not fast, efficient, not big, properly sized. Initially called the 7E7, later renamed the Boeing 787 Dreamliner. 200 to 300 passengers, 20% fuel savings versus anything competing, designed for point-to-point operations. Portland to Reykjavik, Austin to Amsterdam, Nashville to London. Routes that would never fill 500 seats. In 2004, ANA became launch customer, ordering 50 aircraft. The aircraft that would kill the A380 was now real. While Boeing built their future, Airbus encountered disasters. Each A380 contains 530 kilometers of wiring, over 300 miles of cables threading through one aircraft, wings manufactured in the UK, fuselage in Germany and France, tail in Spain. Everything converged at Toulouse for assembly. When German wiring arrived and technicians attempted connecting it to French sections, nothing fit. Different teams used different software versions. Thousands of cables designed to connect simply did not match. 2 full years of delays resulted. Development costs exploded from 9.5 billion euros beyond 14 billion. Airbus stock crashed 26% in one day. The CEO resigned. Production leadership resigned. Complete executive turnover. The Boeing 787 was accumulating orders rapidly. By the time Singapore Airlines received the first A380 in 2007, Boeing held over 600 Dreamliner commitments. Final totals tell everything. The A380 reached 251 orders. The Boeing 787 surpassed 1,800 orders, 7 times the volume. Emirates became the A380's lifeline. Tim Clark bought 123 aircraft. Nearly half of total production went to one customer. At that volume, economics work. Maintenance costs drop. Training standardizes. Part supply makes sense. But this created fragility. One airline represented almost half the orders. When Emirates stopped buying, nobody replaced them. The A380 had Emirates, not a customer base. A single point of failure. Another problem proved equally fatal. The A380 needed airports rebuilt. 30% larger than the Boeing 747. Runways required widening. Taxiways needed reinforcement. Gates demanded double jet bridges. Baggage systems needed doubling capacity. New York and New Jersey Port Authority spent $175 million modifying airports for A380 compatibility. One city, multiply globally. This created a trap. Airlines would not order without airport capability. Airports would not invest without airline commitments. Each side waited for the other. The Boeing 787 avoided this completely. Fits any gate a Boeing 767 uses. No runway changes, no special bridges, no infrastructure spending. Airlines could deploy Boeing 787s anywhere tomorrow. Airports required zero modifications. When Boeing announced the Boeing 787 around 2003, Airbus dismissed it. They claimed no competitive response was necessary, called it an A330 reaction. They were obsessed with the A380 and ignored the generation's most important aircraft. Airlines disagreed. They demanded Airbus compete with the Boeing 787. Airbus eventually proposed the A330-200 Lite. Same fuselage with new wings and engines. A quick fix. Airlines rejected it. Singapore Airlines said, if you are designing new wings, tail, and cockpit, design a new fuselage too. Qantas rejected the proposal and ordered Boeing 787s. Airbus went back to square one. July 2006, they announced the A350 XWB. Complete redesign. New composite fuselage. Wider cabin. Entirely new aircraft. Singapore ordered 20 within 4 days. But redesigning cost Airbus 2 years. Budget exploded from $5 billion beyond $15 billion. The situation was absurd. Airbus simultaneously claimed the A380 represented aviation's future, while airlines forced them building smaller, efficient twins, representing everything opposite. Numbers are definitive. The A350 received over 1,500 orders. The A380 got 251. The aircraft Airbus resisted building outsold their flagship 6-1. Boeing read the future correctly. They bet on smaller, efficient, point-to-point aircraft. The market validated them nearly 10-1. But Boeing nearly destroyed themselves executing. The Boeing 787 arrived 3 years late. Batteries caught fire. The fleet was grounded in 2013. Quality problems persisted for years. Boeing spent $32 billion and still has not broken even. Airbus read the future wrong. They spent $25 billion on an aircraft the world rejected. But Airbus survived because the A350, the aircraft they were embarrassed into building, became one of history's most successful wide-bodies. Boeing saw the future correctly and almost went bankrupt building it. Airbus saw the future wrong and survived because airlines forced them building the right aircraft anyway. The A380 died because one company anticipated change while the other did not. Boeing killed the A380 without building a competitor. They just built what the market actually wanted.